Hello friends, this is Dr. Mohammad Aslam FCA from PLS tutorial. In our previous video, we discussed partial least square structure equation modeling PLS-SEM for no moderation model. Today, we will discuss PLS-SEM for moderation model. Smart PLS-3 software is used for today's discussion. Its setup file with license key are provided in our earlier videos. Today's studies materials and dataset are provided with the link for you download and use. You can contact us by email, Zoom, or WhatsApp for further assistance. The PLS-SEM seems hotcake for social science research recently. It has been widely used in latest articles published in high-quality journals such as Web of Science and Scopus. Because it can deal with multiple variables containing multiple indicators or items for factor analysis and regression simultaneously. It is termed as third-generation statistics for social scientists. We emphasize its applicability rather than technicality and used hypothetical theory and dataset for your easy understanding. Let's discuss PLS-SEM moderation model building and reporting with multiple variables and multiple indicators or items for this example. Moderator variable means it can change the existing relationship between dependent and independent variables. For example, we get from previous literature that customer attitude is associated with customer loyalty. Appropriate references are required for this relationship. Say, Paul et al. 2020 found this in their study. But what if customer switching cost is high in the given scenario? Customer may not leave their existing company, goods and services and still maintain their loyalty even they have unfavorable attitude towards their respective companies. Therefore, switching cost becomes a moderator variable between customer attitude and customer loyalty. If switching cost can be influenced the relationship between customer attitude and customer loyalty, then this is the sign of moderation. Otherwise, no moderation. Now, we want to explore this relationship either to confirm or to reject with Paul et al. 2020's aforesaid findings by our own research and own dataset. Firstly, we get customer attitude as independent variable observed through only CA1 means customer overall attitude towards the company. Secondly, we get customer loyalty as dependent variable observed through CL1 to CL3, where CL1 means customer commitment, CL2 means customer return, and so on up to CL3. In this model, we will discuss moderating role of a third variable because between CA and CL. Then, thirdly, we add switching cost as moderating variable observed through SC1 to SC4, where SC1 means far distance, SC2 means high delivery time, and so on up to SC4. In PLS-SEM, variables are referred to constructs that are observed or measured through reflective or formative indicators or items. In this discussion, we make our model through reflective observed indicators like CA1, CL1 to 3, and SC1 to 4 to represent their represented respective unobserved construct, namely CA, CL, and SC. Let's assume our research is based on primary data. After setting the aforesaid indicators for independent and dependent construct, we need to prepare questionnaire for data collection. Here we use 7-point Likert scale for respondent score. How to entry data in Excel sheet from filled up questionnaire and then transfer to CSV format for smart PLS-3 data read are discussed in our videos. Hope you have seen those videos and practice those working files for your understanding. Please open your installed Smart PLS-3 software. Interface will appear like this. Click New Project on your toolbox and name as Moderation Variable. You will find the newly created project in the Project Explorer. Then double-click its data icon to import data from Moderation Model database file provided with these videos. Software will read the data and becomes green, mean ready for operation with the dataset. Produce moderation model dataset txt that showing report with indicators, indicator correlation, and raw file. Let's start this new project moderation. Put OK. Double click to import the data previously saved in the CSV format. Moderation model open. Then I put OK. We got the data. Moderation model dataset txt. This is indicators, this is indicator correlation, this is raw file. All 10 indicators, age, gender, CL1 to CL3, CA1, and SC1 to SC4 are shown serially with no missing data and displaying mean, median, minimum, maximum, standard deviation, excess cartoonist, and skewness. These are the things we're talking about. Although PLS-SEM is a non-parametric test where no need to assume normal distribution, but even we want to know our data characteristics. We know that perfect normal distribution contains mean 0, standard deviation 1, skewness 0, and kurtosis 3. Acceptable values of skewness fall between -3 and +3, and kurtosis is appropriate from the range of -10 to +10 when utilizing SEM, Brown 2006. For this reference value, we get our dataset more or less normally distributed, which is a safer side for the researcher. Indicator correlation gives primary relationship among them, and raw file is exactly the same data set we have given input in our Excel sheet. Now, our moderation model. Moderation analysis will be performed to assess the moderation role of SC between CA and CL. This example is studied moderation effect through the following moderation model. Direct effect, customer attitude to customer loyalty. Research objective 1. To find out whether customer attitude causes customer loyalty. Respective hypothesis will be customer attitude causes customer loyalty. Again, research objective 2, to find out whether switching cost causes customer loyalty. Relevant hypothesis H2 will be switching cost causes customer loyalty. Now, indirect effect. Customer attitude, customer loyalty. Switching cost will be treated as moderator. Research objective will be to find out whether switching cost had a moderating role between customer attitude and customer loyalty. Relevant alternative hypothesis 3 will be switching cost has moderating role between customer attitude and customer loyalty. Moderator SC, customer attitude to customer loyalty. Let's build our model in our dataset. We need to double click on the figure icon just below the PLS moderation model project in the project explorer. Here, it shows moderation SPLSM, which is an empty canvas, look like this. Please note that software bottom left show indicators. Now we select together CA construct indicator CA1 to bridge into the canvas. And alternate and name it as CA. Now we go for switching cost SC1 to SC4. Put over there, rename SC. We'll align at top as per our convenience. Then CL1 to CL3. rename CL. We will right click. Now there is a zoom issue here. If we do the zoom a little bit adjustment, it will be okay. Okay. So we select the connect tool, then to connect the latent variable. This one to this one, then SC to CL. Then we neutralize the cursor by putting select. Now you see, suddenly our model turns green. It means the model is ready for operation. Now, first we prepare measurement model to check whether the model is fit for further analysis. If it is fit, then we prepare a structural model to find out ultimate research objective, that is the relationship among construct with their respective significance level. Before that, we need to add moderating effect. So our moderator is switching cost. Our independent variable is customer attitude. We follow calculation method, product indicator, standardized and automatic. Then we put OK. Our model is ready for PLS algorithm. That means measurement model. Now we go for calculation. Calculate PLS algorithm. We go for factor for measurement model, then start calculation. The report is being ready. Okay, it's ready. From there, we will find the final result, quality criteria, interim result, and base data. And under this, we will find our required values, outer loadings. Then we got construct reliability and validity, discriminant validity. All this we will put in our report later. Let's find the figure first. This is the figure. It is the more or less the same figure here. Okay. And we find figure 1 for our reliability and validity. Now, from this algorithm 1, we'll find the outer loading. This is the outer loadings. We copy from here, paste to the Excel sheet, and then from Excel sheet, we bring it for our reporting. These are the values, we bring it from here. And we delete the product. This product is not required. Other, we will only take the items. And we see that threshold value is zero 0.6, which is made by this criteria. So we can say our decision is retain the items. Now for construct reliability, we go for construct reliability and validity. Here is the cron batch alpha, row alpha, and composite reliability. We pick it from here and we find the decision, then yes, it is construct reliability has established. Now we got construct validity. For construct validity, we at first go for ABA value. This is the ABA value, it is more than 0.5, so the decision is valid. For discriminate validity, we have three criteria. The first criteria is the Fornal locker. We put it over here and we find that this diagonal value are more than this non-diagonal value, so it meets the criteria. And then the cross loadings, we'll get cross loadings from here. These are the values. Again, we ignore this product because we are calculating in the product method. Here the cross loading, the respective loadings will be more of the item than the other item. These values are more for CL. These values are more for SC. So it also established the criteria. Now STMT ratio, we'll get it from here and it meets the threshold level of 0.9. Again, we ignore this row, this column, sorry, this row. Now, given the aforesaid calculated value, the model is fit for further analysis towards structural model. Now we go for a structural model. This is our structural model. From this figure, we calculate bootstrapping. Then we go for no sign change, complete bootstrapping, bias corrected and accelerated bootstrapping, two-tail test, and 5% significance level. Then we go for path analysis this time and start calculation. The software is taking a little bit time to calculate it. The report will be ready very soon. Yes, the report is ready. So we got the report. At first, we got the figure. This is the figure. This is the figure. We put here inner model, path coefficient and p-value, outer model blank, and here the absolute values. Then we find this figure and this figure is the same. We find that this is significant, and this moderation is also significant on 10% significance level. So this figure and this figure is the same, and we got the evidence of moderation. The significance level we put here 7%, although conventional rule is to put it 5%. Now let's put it on 7%, 10%. This is the figure. Now we'll go for model quality from bootstrapping results. At first, we go for R square. This is the R square value. We find that 52.5% variance in customer loyalty can be explained by customer attitude and switching cost, and this is statistically significant. So we have established the predictive capability of the model. Now we will go for the path coefficient. The path coefficient value is there. We will get it from path coefficient. This is the value. Again, we ignore the moderating for the time being. You see, this is the criteria. This is the value we have given model, and in the middle values moderating effect, this one we put it over here, and we find that the moderating effect, the p-value is 0.07, which is close to this, and we can say that it is significance at 10% significance level, although earlier we have said that conventional significance level is 5%. Okay, now we see from this that the beta coefficient is positive for both the cases, and the p-value is significance, and this confidence interval which doesn't contain zero also uh, prove that the hypothesis is accepted, and we can also see the p-value. So both the hypotheses are accepted, hypothesis 1 and hypothesis 2. For the moderation analysis, we see that beta coefficient is negative and it is statistically significant at 0.059, very close to 5. So our decision is there is moderation. The decision criteria we have established earlier: if moderation effect of the moderator on dependent construct was significant, then moderation absent. Then moderation present if the moderation effect of the moderator on dependent construct was significant. We find it significant in this case. So we accept decision criteria moderation present, number 2. Now, how could we conclude? Following the aforesaid criteria 1, the moderation effect of switching cost on customer loyalty was significant. Therefore, there was moderation on this model. Normally, the customer attitude is associated with customer loyalty to the company. For favorable attitude, they become more loyal. However, switching cost can influence this relationship. Due to high switching cost, for example, far distance, high delivery time, etc., the customer will not switch to the company, rather keep loyal to them even though possess adverse attitude. So we know that some people are familiar with a particular company, but they do not assume a favorable view on that. But they are not ready to switch the company, because if they switch, their switching cost will be higher to switch in the other company. So they remain the same. So here we find the switching cost is the moderating variable for customer loyalty. Thanks for your time. I hope this helps in your future teachers. See you on our next video. Thank you. Thank you very much.